Uh,
Sorry, Professor, we actually can't see your screen.
oh, you can see my screen, right?
No, we cannot see it.
Okay, give me 1 second. So what about now? Can you see now?
Yes, thank you.
Yes.
Okay, thank you so much. Good morning, everyone. I want to welcome you to another statistical topic. Of course, today we had a lot to do, and all what I just need from you is to pay attention. Um, the topic today is probability application in system reliability, and of course, before we start that particular topic, I promised yesterday that I was basically going to show you how the celebrated city case can actually, be navigated using what I call base rule that you've learned, and we can, how statistics can actually help to guide your decision making in the court of law. So the outline, and that was why I said four of us going to walk you through this application in life. Then I'm going to go to system reliability. Okay, so there's an very celebrated case of the century in the United States, specifically. This happened in the state of California, in Los Angeles. But before I go into this case, four of us want to demonstrate the connection between, um, you know, trial in the court of law and, with the base theory. Now, I've walking through this theory in this class. Let me tell you, in any criminal case, okay, when crime is committed, there's going to be some hypotheses. There's going to be some hypotheses, and these hypotheses, they basically form our belief. We call them prior. Okay, we call them like prior. We call them like prior belief. I told you the other time, our mind can never be empty. There's always going to be something in our mind. So when a crime is committed, basically we're going to have series of hypotheses that see one, they are mutually, exclusive, and actually, say they are mutually exclusive and mutually exhaustive. Okay, because one of them will be true. It is not all of them that will be true. It's just like in the court of law, where they're going to ask an accused whether he's guilty or not. An accused cannot be guilty and not be found guilty at the same time. So that is basically going to, that's going to form the hypothesis. And of course, the hypothesis that you see, we have their own corresponding probability. I told you the other time, when you have an event in a sample space, of course, there exists probability associated with event. Of course, you remember what we call the probability space. the probability space have what I call the omega, which is the sample space. They call it F, which is some event, and the probability measure. Okay, so this guy here is basically going to have is corresponding probability. Okay, the corresponding probability we actually going to refer to them as prior probability. Okay, the prior probability is a probability of the state of nature before seeing evidence, before you cite evidence at all. What's your belief? Okay, and that's exactly what we mean. But let me tell you this. So because of that, I'm actually calling this C1, C2, C3 up to CN, like I said. They are actually set of hypotheses. Okay, they're actually set of hypotheses. Now, we're going to have another event that I'm going to call new information. Okay, I'm going to say E. Okay, which is going to be called new information. Okay, new information now is the evidence. Okay, now the question now is, how does our belief change after seeing evidence? Of course, that will require the knowledge of conditional probability. Initially we believe on something, right? Before seeing that, right? Before seeing the evidence. Okay, and when we now see evidence, okay, and of course the evidence is, I know, there's basically going to be a DNA evidence that will be left on the scene of the crime, and through forensic analysis, of course, they basically, going to detect that is going to form as the evidence, and of course, somebody will be accused when the DNA found in the crime scene matches the DNA of the accused, and that is why somebody can be accused, okay, for something. Okay, so that is exactly what I mean. Now, let me tell you this in form of the base rule. Now, the question now is, after we had a belief before seeing evidence, and after seeing evidence, okay, we need to update our belief. Okay, that is exactly how Reverend Thomas Bailey 1759 put that. Now, if I were to write the base theory now, yeah, I'm using C and E, right? I'm using C and E. Those of you online, I believe you can see what I wrote on the board, right? Can you see my board?
Yes, we can.
Thank you so much. Thank you for confirming that. Now, the probability of CI given E. Don't forget, CI set, C1, C2, those are the set of hypotheses. Giving what? Evidence. Oh, I've already seen evidence. Now, what is the probability of the hypothesis being true? Okay, and that is basically, I'm actually going to have E given CI, okay, and I'm going to have the probability of CI, and this is going to be divided by the probability of the evidence. But let me tell you this. The probability of the evidence is basically going to be a total probability. And evidence can be found. There are two things that will happen. Evidence can be found, okay, when hypothesis is true. Evidence can be found when hypothesis is not true. Does that make sense now? Okay, now if evidence is found on a crime scene, that doesn't mean an accused person is guilty. And that doesn't mean an accused person is not guilty. Okay, there are two possibilities. So because of that, this probability of the evidence now is basically is a total probability that I'm actually going to write as this guy now. Okay, plus. Any question? You know what that means? I told you I understand my mathematics by way. If you can relate, this mathematics is easy, the simplest subject on earth. Take a look at it. This is a total probability. The total probability here, everything here is the probability of the evidence. What am I telling the world? The first scenario, evidence can be found given the hypothesis is true. Evidence can be found given it is not. Yeah, what is your question?
So, if we were ever given P of E, could we just, like, we can interchange them pretty much?
Interchange what?
So, like, let's say, so you know how you wrote the total probability because we
Yeah.
didn't have the probability of E? If we did have the probability of E, could we just use the formula that you put before then?
Yeah, today I'm using A and C, right? Somebody can say A, B, but provided you define your A, like right now, I'm talking about C as set of hypotheses. I'm seeing E as the evidence.
Yeah, I'm just saying, like, if you had the probability, you know how you have on the board that whole thing equals probability of E?
Yeah.
And like, because we don't have probability of E, we're using like that top part. But if we did have probability of E, could we just use the bottom part?
Oh, I get what you mean now. That's the reason why I wrote it this way is because we want to figure out the probability of E. And if we have probability of E already, of course there's no need. But let me tell you this. I'm just trying to tell you how the probability of E was derived. And also trying to notify you that the probability of E is a total probability. And what makes it a total probability is, in this case, is that an evidence can be found and an accused person is innocent. And another possibility, an evidence can be found and an accused person is guilty. Does that make sense now? So that is, it's like we're partitioning the evidence into two states of nature. Okay, now, the moment you understand all this, we basically can find. Now the question, now what we now want to go into the Simpson case now. How does this apply? But before I'm going to go into the Simpson case, there's another very, apart from the Bayes rule, okay, and I need you to pay attention to what I want to write now. Apart from the Bayes rule, there's something that we call the odd of posterior. Actually, can you write the odd of posterior equal to the odd of prior multiplied by the odd of the likelihood? Because you know why? Posterior is what we use in Bayesian statistics. The posterior is a combination of the prior belief and the likelihood. Okay, it's like the prior belief is the probability of the state of nature before you collect data at all. What was your belief? Then the likelihood is the evidence, is the data. Now that so the idea we use in Bayes is more or less like combining my belief when I've not seen data, okay, with my belief when I see data. Okay, the combination of the prior and the likelihood will give us posterior. Okay, because the posterior is the object. Now, I need you to pay attention to this now. Because what I'm going to write now is what we're basically going to use in the Simpson case. Because there was a tactical error, okay, academic error in the statement of his defense lawyer. His defense lawyer, talking about something, and we basically want to prove it wrong today using this. Now, when I talk about, so if I have the probability of C given this divided by the probability of this given this, I'm talking about odd. Okay, when I talk about odd, I'm talking about the ratio of two elements that are conflicting. Now, what is the meaning of this? The probability that this hypothesis is true when I say hypothesis is true, maybe the probability that an accused is guilty, okay, the probability that an accused is guilty, given evidence, divided by the probability that an accused is not guilty, given evidence. This is the heart of posterior, okay? This is the heart of posterior. We're also going to have the heart for the prior. Don't forget, we're not talking about prior, the prior belief, before we see that out at all, right? We got to believe, right? And that is basically what it is. Don't forget, that will be centered on the hypothesis. I told you, hypothesis is the prior belief. Now, you know what this guy is, you know what this ratio is talking about? This is a probability that an accused may be guilty, and this is a probability that is not. This is a marginal probability. This is unconditional. Why is it unconditional? The prior is always going to be unconditional because the prior information is a probability of the state of nature before you see evidence. You have not seen evidence at all. Okay, now we're also going to have the odd of likelihood. Okay, this is where the evidence now, okay, the probability of E given C, okay, divided by the probability of giving that. Please take a look at this. This is very, very important. Okay, we call this odd posterior, the odd of posterior equal the odd of the prior multiplied by the odd of the likelihood. Now, we want to go into a Simpson case now. In June 12, 1994, of course, the ex-wife of Simpson and his friend they were murdered. Of course, the prime suspect happens to be Simpson. You know, Simpson was, an American football legend. Apart from being American football legend, he actually, was acting in the movie commercials, and at the same time was actually working with NBC as a football analyst. And you know what? The fact that the murder suspect has previously physically abused his wife, played an important role in the trial because the LAPD, the Los Angeles Police Department, uncovered that Simpson had previously abused his wife, and not only that, of course, that as at that time that was the ex-wife, and of course they also discovered the hand gloves, because when I told you Simpson was actually also working with the NBC, and he used to put on the hand gloves, and that very gloves is similar to the one found on the crime scene. Okay, so and the hand gloves actually found on the crime scene as the blood that matches the DNA of Simpson. Okay, so based on that, Simpson now was a prime suspect in the case. But let me tell you this: one of the Simpson lawyers argued that he said he tried to belittle the relevance of the history of abuse for Simpson. He said it's only 0.1% of men who physically abuse their wife actually end up murdering. Okay, and he believed that because this probability is very, very small, therefore Simpson should be in the charge and accused. But let me tell you this: we want to disprove this. 0.1%. Okay, the lawyer here did not really consider the fact that somebody was murdered. Okay, he did not, So these are other informations. But let me tell you this: in 1992, 4,936 women were murdered in the United States. Okay, of which roughly 1,430 were murdered by their ex-husband or boyfriends. And in addition, assuming that a woman has been murdered by someone other than her husband had a chance of being abused by her husband equal to 0.05, and a woman who has been murdered by her husband had a chance of, being abused by her husband equal to 0.5. Now the question now, was the fact that O.J. Simpson had previously physically abused his wife irrelevant to the case? That is what we want to show the world right now using our mathematical principle. Because the defense lawyer argued against that because 0.1% of men who abuse their wife will end up murder them. That is very, very small, and because of that, is ruling out the fact that the accused is guilty. But what we actually want to do now is to be able to investigate. But before we investigate that, I'm going to show you the picture. That is the O.J. Simpson. And of course, we want to prove to the world why the statistics used by Simpson lawyer was a very poor one. We want to prove that because you know why? Why were the statistics poor? The statistics poor because that ignored the fact that Simpson wife was actually murdered. What is the relevance is the probability of abusing husband is guilty, given wife is murder. That is what we need to find. But what the lawyer was talking about is the probability of husband murders a wife, giving husband abuses wife. There's a difference between the two. I need to pay attention to what is being displayed right now. What we need to show is the probability of an abusive husband is guilty, given wife is murdered. Because the event of wife is murdered supposed to come first. Before you now talk about whether the abusive of her husband is guilty. But do you know what the way the Simpson lawyer interpreted that? He interpreted that as the probability that husband murders wife, given that husband abuses wife. The two are not the same. The same way that this guy is not the same as this guy here. Or they are not the same. That is the same way that is not the same. Now I need you to pay attention now. And we basically, based on that information, we actually we're going to see how that is going to play out. Okay, so give me 1 second. Let me see where Now, what we're basically going to do is this. What we want to prove to the world is to prove, because the Simpson lawyer was trying to say that the fact that Simpson abused his wife was irrelevant to the case. But you know what we want to prove now? We want to prove that that was relevant. Does that make sense? That's exactly what we want to prove. Now, if you want to start the proof, we're actually going to define some events. Now, we need to pay attention now. Event G. So the event that husband is guilty of the murder of his wife. That is event G. I wrote something the other time. C as hypothesis. I'm using G now. You can use whatever, but provided you define what that represents. Now, another event N, okay, the event that the wife has been murdered. okay, the event that husband has physically abused his wife in the past. These are the three events we consider. Don't forget, what do we want to prove to the world? The fact that the history of physical abuse on his wife by the accused is irrelevant to the case, because the lawyer, the defense counsel said that is not relevant, and he was using the statistics that because 0.1% of husband that abuse will end up killing their wives. Now we have written these three events. Now the probability of G giving men is this. Of course, from here, you have been given that. Because this was a case, the murder was committed in 1992. And the data available in 1992 shows that 4,936 women were murdered in the United States, and of which 1,430 were actually murdered by their ex-husbands or boyfriends. And that was why, take a look at this. That was what led to this, 1,430 divided by this. So which means what I will try to do, the probability of killing, given that the wife has been murdered. Does that make sense? Okay, who is guilty? The husband. Okay, this is what this is talking about. Now, do you know I can also find this? You remember the other time? It can be guilty or not, right? So which means I need to find if the probability of G giving N equal to this guy. If you remember the law of complement that we've been doing, we can find this guy, which is going to be 1 minus that guy, right? 1 minus this guy. Okay, which is going to be 1 minus 0.29. That is 0.71. Because you know how I derive that. Because you know why? When I have this, why do I need to go for that? Because I want to use odd of the posterior equal to the odd of the prior multiplied by the odd of the negative. That's why, that was why I need to actually obtain. Now, the next thing that I want to find now is the probability of E giving G N. Look at that. The probability that husband has physically abused his wife in the past, given that he's guilty, and given that the wife has been murdered. Okay? And you know what? That has been given in the question. Pay attention to the question. Take a look at that. That is 0.5. It said, I needed to look at that. A woman who has been murdered by her husband had the chance of being abused by her husband is equal to 0.5. Okay, which is what this guy actually stands for. That is what it stands for. Okay, that's 0.5. Now, another information is the probability of A given this, okay, and equal 0.05. Do you know how I got this guy? How, right? You go back to the information given. Look at the information given. Okay? That a woman who has been murdered by someone other than her husband, if she has been murdered by someone other than her husband, that very G is going to be a complement. You know what G complement means, right? Not guilty. But this guy here, guilty. These informations are provided. So right now, okay, a P bar is equal to 0.05. Okay, that's what I have here. Now, when you take a look at what I have now, and what I have now, then these are what we need to get the odd of the posterior. Now, so if I now want to, write, I want to, you need to now remember the odd of the posterior equal the odd of the prior, okay, multiplied by the odd of the prior. So I'm actually going to have this divided by this equal this divided by this multiplied by this divided by this. You see, you know what we want to find? We want to find this. We want to find the odd of posterior. The odd of the posterior is the odd of prior, okay, and the odd of likelihood. Okay, now let us come here now. This guy is this guy, 0.29 divided by 0.71 times what you have here is 0.5 divided by 0.05, and that gives us 4.08. Okay, that gives us 4.08. Now we have 4.08. This 4.08 is actually the odd here. And you know what? We now have, if I have 4.08, so don't forget what is equal to 4.08 is basically PG of this. Let me first ask you this question. When an odd ratio equal to 1, what does it mean? Equal chance, right? But the odd ratio is greater than 1. When odd ratio is greater than 1, it's favoring this. What is it favoring? Guilty. Does that make sense? If this guy is less than 1, it's going to be favoring this guy. If you want to talk in terms of odd ratio. But if we want to continue to trying to simplify all of that, take a look at this and this. Do you know that this divided, this guy is here? The law of complement. You remember the law of complement? Okay, the 1 minus that. Does that make sense? You remember what you have here is what you have here, but this is complementing that guy. Okay, as you can see. Okay, now if you this is not going to have a complement anymore, because what I'm trying to say, the complement here will be 1 minus this. Does that make sense? So this is now equal to 4.08. What are we looking for? We are solving for this, right? So when you solve for that, okay, you can let x be equal to this guy. Okay, you can let x be equal to that. So that's going to be x over 1 minus x. Oh my God, I remember when you are solving the equation in high school, you're going to say, well, what are we doing here? See, we've solved it into equation now. We're going to go back to the high school now. So we're going to solve for x, right? So it's going to be x equal 1 minus x into 4.08. By the time you solve for x, finally, you're going to get 0.8. When the probability is 0.8, that is highly likely. What have we proved to the world? We've already proved that the probability, the fact that this guy has history of abuse on his wife is highly relevant to the case. Because the probability is so high. This is disproving the let me just say the perception of Simpson's lawyer. Does that make sense to you now? So what we've just done now is proving that that is actually relevant to the case. Any question? Any question? But let me tell you this. The idea of debates have been used in law practice, but at times it will confuse the jurors. Of course, you know, the United States run a jury system, right? Because when you say 1 in million, the 1 in million may be interpreted by one jury as very small and may be interpreted by another jury as plausible. And that's why at times the Bailey's rule confuse jury because they will have different perception about how that can be interpreted. Okay, so that is how I'm going to go on that.